Ngalakin Khadijan Nyunga Boja.
They're used, in fact, there's still big argument going on between GPU people and FPGA people as far as the correlator is concerned, because one is more programmable than the other, but the other has lower power requirements. Okay.
If there are no more questions, I will thank Lister for this interesting guest lecture.
Thanks. It's been a pleasure.
Out of that design description.
Good. Thank you.
Thank you, Lister.
Thank you very much. Sorry.
Your USB sticks. Could I make a copy of that?
Yeah, take it now because it's quite large.
Yeah. Okay.
So we've got a second speaker for the next session. So if you want to take a quick break, grab a coffee, water, whatever, so you're all refreshed and ready to go. The scale of your problem is quite
Fortunately, it's not
mind-boggling.
my problem.
Well, I noticed you used some Yagi over there as well, so these logging things, right?
Yeah, it's a little bit different from a Yagi. This is log theoretic is sort of got a wider frequency.
So that,
Similar.
but that trade-off is always, wider frequency lowers your gain, right? So you could always design a narrow band and have higher gain. So that was a trade-off that was made. At some point, you want to look at a wide band of that sky. Do you get any advantage by going with just targeted these one set of frequencies? The rich amount of information out there, and our game would be so much better if we just were narrow band.
Yeah, there was a competing antenna design at those lower frequencies using a simpler dipole, like a cross dipole, just high off the ground. It was a bit like a line dipole.
Yeah, thanks.
So you got a USB stick?
Yeah, that was the easiest thing
Yeah.
doing. I bought a laptop as a backup,
No.
but this will be the...
Can I make a copy of this if you don't mind?
Sorry?
Can I make a copy of
Oh,
it?
cool. Yeah, no problems.
In the end, it's about the fact is we don't know what is going to be in frequency. And it's a facility.
It's yours?
Facilities are meant to
Support a whole range of different words, and then just
So that's the way it went.
it's
It's certainly true. You could make something more cheap, more targeted, more quickly.
it's going to be. I'm not sure. That's very much appreciate
You okay with the recording?
Yes.
Let me know.
Thank you very much. So Joe's, we saw Joe in,
For this lesson.
for this spot. So apologies for not.
No, I was watching the emails going back.
That's fine, don't worry. Yeah.
But again, because the electrical, we tried to get some electrical standard stuff going, and we had a few speakers, but that the practical side of electrical standards, we've been really missing. So we.
Yeah. Look, I'm going to focus on, not necessarily, there's a couple of stands I'll talk about.
People should be able to hear that, hopefully.
Do you want to clip it on or?
That goes in the pocket, yeah, that clips on.
So, we'll give a chance for Q&A at the end relating to the requirements. We'll have some time left for a general discussion about the requirements. But we've got Joe Romano from Best Consultants to come by and talk to us about standards in particular and the practical aspects of it. Talk about electrical installations. Really happy that we're getting people like Joe to come by and talk to you and tell you what specific problems you'll start seeing in the industry. So please have a listen. Joe, thank you very much for your time. There will be explain how you want to run it.
Okay.
Either leave questions to the end or interject, your choice.
Hi folks, my name's Joe Romano, Electrical Building Services Engineer. This is going to be a free-flowing discussion session, so we're going to try and chat for 15-20 minutes. I'm going to give you an overview of who I am, my company, and then obviously the building services industry, and then we're going to touch on some Australian standards and also this subject matter you've been given for the interlocking and interfacing of the drill set. At any stage, if you think I'm going too quick, or don't understand something I've said, put your hand up, say your name, and ask the question. Just keep it free flowing. Let's just be as interactive as we possibly can be. Is that all right? Nod your heads. Make sure you're all awake. Great. Okay, so Joe Romano. Been in the industry for over 35 years now. Left school at 15, went into electrical building services. For some reason, I haven't been able to escape it. It's a very, very interesting industry to be in. Every day is a different day, a new day. We work, or I've been working in what's known as the built environment, and delivering real projects. The room you're sitting in, the lecture theatre, the sort of work we do. So, spent the first 15 or so years in the UK, the last 20 years in Australia, in Perth. Got a degree. The scary thing here, I reckon, is I got my degree before any of you guys and girls were born, which is a bit scary for me, but, you know, we're all getting there. The round out, when I came into engineering, a company of about 30 people, we had one computer. That was it. If you wanted to send something quickly, you use this horrible thing called a fax machine. So over the past 35 years, we've seen not just the industry change, but the technology change. You know, no one had laptops. It's quite scary where we are now, and it's going to keep changing. It's going to keep evolving. All right. So I've been around a long, long time. Member of the Institute of Engineers. How many people here are Institute of Engineers members? Anyone? One? Two? Take my advice. You should all be joining as a student. Get student membership. You'll get access to information from them, and also internships, graduateships. So I've got one guy at the moment who's in his first year of graduateship in my business. Came through the Engineers Australia as a recommendation. So if you want to hear about the industry, join them. It costs you peanuts, especially as a student. All right. Best consultants. So when I say the built environment, I literally mean buildings, construction. Things such as you've got Coburn Shopping Centre, massive retail site. It's keep developing, we keep building onto it. Left-hand side is a little bridge in Exmouth. We built the bridge. It's lit at night time, it's colour changing LEDs. The guys in the local council can sit at their tablets now and do a colour changing sequence. The bridge lights up, blue for Exmouth Day, pink for Breast Cancer Day. You can see the bridge from about 25 kilometres away at night time because it glows, but over navigable waterway, so things like that. Classroom in green, don't ask me why it's in green, that's what an architect does to you. And just for a personal note, architects are guys that couldn't quite make it as engineers. Don't anyone tell you otherwise. And then we have fun little projects that we do. Top left-hand corner is another university's art gallery called John Kern. And we relit their art gallery for them and set up a presentation. So we get to do some fun stuff like that. Bottom left is the Gateway project in WA. The largest infrastructure project that WA has seen for 50 years, worth about $1 billion plus. And we looked after all the lighting and traffic management systems and stuff like that. Middle one is the Anzac Museum down in Albany. Something a little bit different, we do. Gelato, because everyone likes freaking ice cream. Okay. Top right, you should all recognise in actual fact, it's one of your buildings here, which is the Indigenous School Indigenous Studies. Yeah, okay. So we get involved. We don't design the camera, we don't design the PC, we don't design the PowerPoint that goes on the wall. But what we do as engineers, we take those products and make them fit a building, all right? And make the whole system work rather than just an individual item, all right? So we're not designing the plastic, we're designing the whole system to make sure it's operational. We staying awake? Good. Well, that's a worry. Okay. Australian standards. How many of you actually picked up or read on Australian standards? It's the most invigorating thing going, really, isn't it? The first question I'm going to ask is, what's an Australian standard for? Why do we have Australian standards? Is it for fun? They're really boring and tedious to freaking read. But why? Come on, someone have a guess. What are they trying to tell us? Okay. Okay. So, to what extent? What level does an Australian standard give you? Is it giving you a working standard, or is it just giving you the minimum standard? Okay. Australian standards are here to demarcate the least amount of stuff you need to provide to get this thing to work. Yeah? It's the minimum standard. So if the Australian standard says you need to make it 20 mil thick, whatever it is, and you're an engineer and you're clever, so you've made it 19 mil thick, you're in trouble. What you should be doing is looking at that standard and saying, why is it 20 mil thick? Why do I need to do that? Understand that, translate that, and then go for 19 if you can prove that's right. So think of Australian standards as your minimum requirement. It sets almost like a set of guidelines. Within the electrical fraternity, there's only one regulated standard, and that's a document called AS3000, which is set there. There's 100 plus electrical standards, but only one is regulated under OC Health and Safety regulations. All the other standards, they're all guidance notes. You've got to comply with them, especially if something goes wrong, but fundamentally they're there for you as engineers to translate and implement. Yeah? But think of Australian standards as the minimum standard. That's your first starting point. Just bear with me, because I think that's a good start. Okay, who decides what's relevant? You're gonna build, let's say you're going to build a light fitting, whatever the product is. You've then got to decide what is relevant. You need to find the right standard, decide the applicable one. So Australia is great because when you have a product, we don't give you one standard, we'll give you half a dozen. So as an example, external lighting, which is AS 1158, there's about 7 or 8 different parts to it. Right? So within a built environment, the starting point isn't the Australian standards, but it's another document called the National Construction Code. So an Australian standard says if you're going to provide something, this is the standard you make it to, or you build it to. The National Construction Code actually says when you need to provide something. So as an argument's sake, when do you need to provide lighting in a building? When do you need to provide emergency lighting? When do you need to provide fire detection? If you pick up a standard, it will just say, if you're going to provide it, this is the standard you need to achieve. But it's not going to say when you need to implement it. That's you as an engineer. Yeah? So the National Construction Code, which was also called the BCA, Building Construction Code, is a document that set out that all buildings have to be constructed to in terms it sets out the provisioning. So it will say in that document, life safety systems will be things such as emergency lighting, fire detection. It doesn't worry about things like power points and air conditioning. It'll worry about ventilation, fire detection, fire management type systems. But that document will then say to you, you need to provide artificial lighting in accordance with 1158 for external and 1670 for internal. All right? So you need to start at the beginning and understand where you're going. Am I going too fast? Everyone's really quiet, which is quite... Okay. Okay, good. All right. So, AS3000. Commonly known as our Bible, our gospel, when it comes to electrical engineering. Right? So AS3000. I'm going to come back to that in a second. So, AS3000. It's quite a thick document. There's a few hundred pages to go through. Luckily, they did remember to break it down into sections, so after a few years of reading it, you can work out where everything is. I just picked out a particular section that sort of relates to the subject matter of the interfacing of electrical devices and stuff. So, we'll get straight into it. AS3000 or AS3000 wiring rules. Section 4, selection and installation of electrical equipment. This section specifies the minimum requirements for the selection and installation of electrical equipment, including appliances, accessories that shall be achieved to satisfy Part 1 of this standard. All right? So basically, if you're going to design an electrical network within a building, you need to comply with AS3000. If you want to plug a device, like an appliance with a hand drill, it also needs to comply with the basis of AS3000. Going sideways a little bit, appliances in Australia don't sit very well within any of our standards, unfortunately. Right? Most of our standards, like AS3000s, are written around the permanent installed equipment. So, for argument's sake, to your light switch or to your power point, and that's where the standard basically extends to. And then it refers to the bit that interfaces to the drill set, as an example. Right? Unfortunately, you have to accept that Australia's 27 million. When you look at the population of Europe, which is a few hundred, and other countries, we're a pretty small country. So we tend to just adopt everyone else's standards. So for argument's sake, if you go and buy a washing machine, don't worry about the fact whether it complies to Australian standards. It's a case of the device it uses to plug into the wall is the bit that does. Because the washing machine, when you open it up, wouldn't comply with anything that we do locally. But it doesn't need to. All right? It's covered by an international standard. So following on with this particular section, electrical equipment shall be selected and installed to perform the following functions or have the following features. Enable the electrical equipment to function properly under the external influences to which it is expected to be exposed. What does that mean? You're engineers now. That hasn't given you an answer, that just pointed you in the right direction. It's telling you whatever you install, whatever you construct, whatever you plug in, it's got to operate within the environment that it is in. So you need to think about, yes, you've gone and bought your drill set or you've gone and bought your washing machine. I'm now going to design a network around it. I'm going to plug it into the wall. That power point or that light, is it designed for the environment? So temperature, humidity, yeah, dust control, all those sort of factors you need to be thinking about. You can't just go and buy any old power point and whack it in the space. The question is, what is the space used for? Who's using it? Under whose control is it? Yeah. Prevent any adverse effects that the electrical equipment might cause on the electrical installation. So you've gone and bought your washing machine, you've plugged it in, when you turn it on, the light's dim. It's drawing too much power in the most basic form. That doesn't actually happen nowadays, thankfully, but what you've got to think about when that, as part of that equipment selection is, will it impact on the rest of the building? Yeah? And that can be electromagnetic interference, that's the big one nowadays, or it interrupts or affects the power quality of the building that you're in. Yeah? Keep nodding head. The next one's obvious. Operate safely when properly assembled, installed and connected to the supply. Don't give anyone electrocute anyone. Right? So you should be able to manufacture, purchase a device, plug it in, turn it on if it's properly installed. Yeah? That's common sense, isn't it? You'd be surprised how much people lack it. Ensure that there is no danger from electric shock, fire, high temperature or physical injury in the event of a reasonably expected condition of overload, abnormal operation, fault or external influences. Back to this external influences thing. So again, you bought the washing machine. Will it work? What will happen when I put it in the space? It's in a high humidity space. Yeah? Will someone get a belt from it on execution? Installed in accordance with the regulations. So the next sort of stuff is blurb. So I won't worry about that. I just thought I'd chuck this one in as well, emergency switching. So again, within a lab environment, what tells you when you need to install an emergency stop system? There's a standard here, it's a clause 2351 that gives you an outline, but you're the engineer, you need to understand what the risks are for the user and educate the user and what needs to be provided. 9 times out of 10 your client will not know that they need an emergency stop in their lab or their workshop. All they're concerned about is they're making a bit of steel work and they just want to bend a bit of metal. That's their job. Yeah? They don't realise or appreciate that you as the engineer, you're putting the electrical system in. It's up to you to tell them what the safety requirements are. All right? So, means shall be provided for an emergency switching of any part of an electrical installation where it may be necessary to control the supply to remove any unexpected danger. So it's a lathe, someone's got the hand cord in it, there's an emergency stop, you can hit it, you kill the power. Where required, because of the risk of electric shock, the emergency switching device shall be of an isolating thing, so it turns the power off. The arrangement of the emergency switching shall be such that its operation does not introduce a further danger, interfere adversely with the compliance operation necessary to remove the danger. Yeah? Item 1. Notes. Emergency switching may require switching off or switching on. In an emergency scenario, when would you want to turn something on?
Red light.
Okay. Actual fact, you're not too far off then. We have done labs where basically when there's been an incident, they hit a button, a red light comes on to advise the tech outside there's a problem inside the space. But another space issue you can have is when you have a discharge, so you've got a fume cupboard that's not working properly and gas leaking out, they can hit an emergency button, it kills the power to the fume cupboard, but then turns the ventilation to on. Yeah? Okay? So those are the sort of things you've got to think about. Examples of electrical installations where means for emergency switching are used are as follows. First one, machinery. Exactly what you're looking at. Conveyors, groups of machines. All right? I'm going to hop back a little bit. So, we've spoken about A3000. Australia, unfortunately, the standards are very good at hiding all the documents you need to find. So it would be really nice if the industry would take all the electrical standards and pre-categorise them by, say, the number 3. So you're on electrical standard, you start in 3000, you work through the whole series. If it's concrete work, you start in 6000. It would be really good if they can organise that, but no. We like to make it a challenge. So A is 3000. And the next relevant standard for you folks is something called 4024. And 4024 is to do with interlocking. Yeah? I don't know why it's a 4024 system. It seems almost like a number they pluck out of nowhere. But if you go on to SI Global, which is Australian Standards website, you can do a search for interlocking and the like, and it will give you a long list of standards that you can cross-refer to. As students, do they get access to Australian standards?
Yes, it's one of the major advantages of
Right.
student things.
Yeah, use it as much as you can now before you leave. It costs a frigging fortune when you leave. I know, pay enough for fees for it. So I'll just pull this out as a reference example, so you should actually read this if you're doing this assessment. All right. This standard was prepared by the joint, blah blah blah. Forget the first bit. So sorry, I'll go back a bit. The first thing you do when you pick up a standard, read the preface. All right. Don't skip to the index. Read the first couple of pages. The first couple of pages will tell you if you're looking at the right standard. All right. So that's where you start. The objective of this standard is to specify the principles of the design and selection independent of the emergency energy source of interlocking devices associated with guards. There you go. All right? So read the intro. Don't go straight to the index. All right? I'm going to go back a little bit. That's 4024. Right. The next little thing for you, when it comes to Australian standards or any standards, is that Australia is made up of 7 states and territories, I think is the right term. We all have our own laws, unfortunately. So within WA, we have WA Commerce, which looks after Office of Energy Safety, and they publish policy statements. It's almost at random sometimes, but they do exist, and within their library is a code of practice for safeguarding of machinery and plant. Right? And that gives you guidance of how you make an assessment. Again, first thing you do, read the foreword or the introduction. Is it the right standard? Section 1, introduction purpose. Any regarding of all types of machinery and plant found in workplaces such as augers, power take-offs, food mixers has led to serious injury. So the standard talks about the implications of what happens if you don't do it right or you don't provide the right measures. The nice thing about the standard, it gives you a risk management matrix to work off. Right? So it's not going to give you the answers, but you're the engineer, so you're going to do a risk assessment to work out whether or not that bit of machinery needs the level of control and protection that's been requested. Yeah? Because if you can understand what the requirement is, you're going to fix the problem a lot easier and a lot quicker. All right? Interlocking via card credentials. I will say that using card credentials, which is your access control card, is reasonably popular within the industry. It's a good way of doing it. It has certain complications and certain compatibility issues, but it is a good way. I think all students here get an access control card, the student card.
So they have a student card that doesn't control any other than the door, which is what the project that they're working on about.
Correct. So your access control card, as we call it, is the same div card that you could use for this machine. Right? Effectively, it thinks of the machine as a door and give you the same credentials. Right. First question as an engineer, why? I'm going to sort of split the difference between an electrical contractor or electrician and an engineer. An electrician will typically be given a document, such as the one you've been given, and told, fit the card reader, fit the interface, make it work. Done. He's done his job, he walks away. You're an engineer. The first question you should be asking is, why? Why is the client telling me to fit a card reader onto this device? What's it there for? Is it the only device in the room that needs to be controlled? Or is there 20 more to go? If there's that many in the room, maybe we don't worry about controlling the individual equipment. Maybe we make sure the person can't get in the room to start with. Maybe we should put in the access control in the doorway. Yeah? Is that the better solution? Right? So 9 times out of 10, the client knows what the end result needs to be, and has done a little bit of homework. He's done a bit of this wonderful thing called Google, which is the curse of everybody at the moment, and he's worked out what he wants to do, and he's given it to you. You're, as an electrician, you'll just install it. As an electrical engineer, you'll challenge it. You'll find out what they really want. You'll find out what the end product needs to do, and then you'll make sure you'll provide the best result for it. All right? Hence the why. Ask them. What logic was used to define the control method? Why do we need it? Well, why do we need a card reader? Can I just put a key operation switch on the device, leave the key with the lecturer, and just say, if that student, list of students come in, give them a key? Is that good enough? Why only the drill press? If you've got a room full of gear, does the same system need to be expandable? Can I go in there and just badge on one and use something else? Yeah? As the engineer, you need to have all the answers, unfortunately, which means you need to be asking a lot of questions. Yeah? And there is no such thing as a stupid question. Or rather, the only stupid question is the one you don't ask. When I looked at this as a good example, the first question I'd ask is, who are you trying to control? Who are you trying to get authority for you? Is it a technician, or is it a lecturer, or is it the students? Yeah. The card reader, where does it have to go? Does it have to go on the machine? What's the benefit of putting the card reader on the machine? Anyone? Sorry? Yep. Okay. So your interface device at the moment is a card reader. The actual thing doing the switching is a little controller that sits on the wall that's in a comms cupboard. So by putting the reader on the machine and then moving the machine, hasn't actually achieved too much. But if you turn around and said, okay, if I put the card reader on the wall, I'll challenge you with this, sorry, put the card reader on the wall, I've got a contactor low down, which is switching the power point that's protecting that drill. I can then unplug the drill, move it to another space, give it to a lecturer or a technician who doesn't need the same level of control, use it somewhere else. I can also then bring in a new device, plug it in and use it straight away, because it's already, the interface is part of the fixed installation, not the portable installation. Yeah? So you can use it for different bits of equipment. Right? You've got a card reader. How are you going to fit it to the machine? I reckon this machine is almost as old as me. So it's old and craggy. If you try and drill into it, it's just going to fall apart. So the next question is, you're going to fix a device to a metal box. Have you thought about earthing and things like that, labelling? So it's just a case of ask the questions, keep prodding at it, find out what the client's end result is. Don't worry about I do a lot of work where we do a lot of educational work. I'm sorry about this, but we do a lot of work for UWA, Curtin and a few others, and we always get this, here's a new lab we want to put in, can you put a PowerPoint over there, or can you do this? You go, well, why? And then you find that the machine they're putting in, that's not the right PowerPoint for them. So rather than say, where do you want your PowerPoint, you say, well, what equipment's going in the space? How do you want it to operate? Yeah? Because you're the engineer. You're the one who's going to help them decide and make the right decisions. Yeah? Okay? Everyone sort of stayed awake? I just thought I'd throw this into it as well. IP ratings. 2 digits. First digit is a solid, which tells me it's the old finger test. Can I prod my finger through the wire mesh and give myself electrocute myself? So the first digit is a solid mass. Second one, they refer to ingress of water, can also be gas. So a non-solid. All right? So when you're designing something, you're designing a box, contact or a controller, you need to factor in things such as, what's the IP rating? IP rating of a PowerPoint is IP 21. Okay? A light switch would be 44. And it's all about being able to what you can touch when it's in service. All right? Couple of funny pictures for you. The scary thing is, yes, these are off the net, but they are frigging real. This is what worries me. I reckon I've actually stayed in a hotel somewhere, and the Kirchhoff's Law one, I reckon I was staring at that bloody thing one night. So that's the sort of thing that does happen. It's real. The one on the right, we had a joke about this in the office the other day because it is in this country, unfortunately. You can tell by the PowerPoint, that's an Australian PowerPoint. And we always joke about coordination with other services. So you can blindly design something and be basically ignorant of everyone else. I'm just an electrical engineer, so therefore I'm going to put my light fitting there, I'm going to put my PowerPoint there, I'm going to put the switchboard in the corner, I'm done, move out. But when it all goes pear-shaped or it doesn't fit, you will be fixing it. Yeah? So you need to be able to communicate with everyone else in your design team. So we're electrical engineers, we're in a built environment, we take this room, there's going to be an architect, there's going to be a structural engineer, there's going to be a mechanical engineer, there's going to be a hydraulics engineer, there's going to be a quantity surveyor, and more likely a project manager. No one's doing project management, are they? Good. They're worse than architects. So you need to be able to talk this through. And the reason we joked about this photo with the water, the tap above it, was the fact is the PowerPoint would have had to be moved. No one's going to move the tap. The PowerPoint's going to be moved. So you might as well get it right to start with. All right? Not to be operated by, I won't say it because it's been recorded, but you can work that out. That could be another way of circumventing your interlocking system, because if you're one of those, don't come in the room. And the one on the right, again, that's in the States, but that happens. Water gets into system. Yeah, we had an incident not too long ago where someone was drilling a hole in the concrete slab, and when they core drill, the core drill uses a watery slurry to not burn the blade out. There's core drilling through the concrete slab, and he'd done all the survey work. As he went through, he picked up a pocket which had a plastic conduit in it. Water goes in the conduit, tracked, a good 10 or 15 metres along, then drops straight into a switchboard. So that does happen. All right? It's real. And I keep saying, as the engineer, it's your job to stop it from happening. Yeah? So think about, I keep repeating this, ask the question, think about the outcome. There's no golden rule about standards, all right? There's lots of them. The starting point is AS3000, and then it just gets bigger and bigger and bigger from there, all right? Have I bored everyone enough? Electrical engineers. I found this, I thought this was quite funny. I've got 2 daughters at university, and I think this is what they think I do. The bottom right-hand side, unfortunately, fast asleep. So, electrical building services, I'll just recap on that. It's not, we're not researchers, we don't design little battery packs or the Tesla machines, we design the whole system. We take different components from different manufacturers, plug them together, and make sure they work and operate, and make sure they have longevity to them. All right? I'm going to stop talking because I'm getting hoarse. Questions? And it can be anything. It doesn't have to be about this. You can ask something else. By the way, what's your name?
My name's Nathan.
Nathan.
I want to know what the thought process is when you try to decide between a fuse or a circuit breaker.
Oh, okay. Right. Good question. What we tend to do is first look at the load, understand the characteristics of the load. So is it a machine, is it a motor, or is it just another switchboard with final circuits on? Right. Then we look at the environment it's going in, and then we go, I haven't installed fuses for 20 years, let's not do that ever again. Because fundamentally fuses, unfortunately nowadays, within a normal electrical network, don't exist anymore. Right? They're very old out. But fundamentally, you should be looking at the load and the characteristics. In high voltage installations, so 6 kV and above, main distributed networks, we still use fuses. All right? But fundamentally, you should be looking at the characteristics of what you're to supply. Fuses are far more forgiving for load fluctuations than circuit breakers. Yeah? And the nice thing about a fuse is when you've got a problem and the fuse is gone, fuse blows, you have to go there and fix the problem. We do suffer a little bit of people going back and resetting a circuit breaker and going, yep, that's held, the problem's gone away, and not really fixing it. So I grew up in the era of fuses, so they do have the uses, definitely, right? But tend to be high rupture scenarios, high voltage, high currents.
I'll give my feedback as well. Fuses are fast. Circuit breakers tend to be mechanical and slow. So I used to run a class where we would blow up fuses and measure them on a scope versus circuit breakers, and circuit breakers will take 100 to 500 milliseconds, whereas fuse is milliseconds.
So
what do you want to be connected to when you're being electrocuted?
Yeah. So to sort of circumvent some of the problems nowadays, we have a thing called an RCD. Every house has them, residual current device. To be honest, it was a bit of a cop-out for the industry. It's not good engineering. It was brought in and fixes the problem where a fuse works quickly. You can have an MCB or a miniature circuit breaker that will sit on a fault for quite some time, seconds, when you've got a fuse is gone, and allow enough voltage to get through to actually do harm. So you invented something called a residual current device. Right? And that sort of circumvented most of those problems, but didn't overcome the overload protection problem. Right? So yeah, there's but unfortunately the industry's moved on from fuses more commercially than anything. Unfortunately, people tend to use
motors also tend to blow fuses.
Yeah.
Because their startup current is huge. Whereas a circuit breaker for a motor, it can draw a lot of current, and circuit breaker won't blow because it's got to draw that current for a sustained period. But yeah,
so you can go out and buy you can go out and buy a circuit breaker, the same rating, say a 100 amp breaker, or say a 63 amp breaker, and you can buy a type A, B, C, and D. A is very, very unique in Australia. We don't tend to see them at all. B's and C's are the most common used, and a D is a motor rated breaker to allow that let through current and then to operate. But they're not, again, I have to use the word sloppy in terms of their use. I wouldn't overly rely on them. They're great for short circuit protection, but if the thing's sitting on a partial fault, it will just sit there all day long, smouldering. All right? Anything else? Anyone want to know about the industry or anything in general terms? Does anyone know what they're going to do when they leave here? Has anyone sort of picked a course of action they want to do? Want to go into research? Are you the final year yet, or? Okay. So when do you actually finish uni? This mid-year?
Yeah, you got one more semester after this?
Design one, so design two is
Most,
next
so
semester.
most
So
of
there'll be
you've got maybe to the end of the year.
Okay. So you should be thinking, within the next couple of months, you should be thinking about putting it, well, coming up with some form of CV or a little bit of a, I wouldn't say a CV if you're not working in the industry anyway, a bio about yourself and start flicking them out. The industry at the moment is incredibly busy. All right, incredibly busy. So now's the time. If you wait until the end of the year, everyone else in your class has already beaten you to it. So Engineers Australia, really being the member for a long, long time. I'm a fellow of the institute there because I'm so old. I think they give it to you when you get to a certain age. But they can give you inroads into some of the companies in Perth, all right? Especially when it comes to graduate interns.
Just a question. What would you expect from like a fresh grad in terms of, let's say, they come to your company as a grad engineer? What would you expect them to have? Like, what skills do they expect them to have?
Okay. It's not a design question, but it's a fair question because, yeah, that's fair enough. No, that's it. Okay. Unfortunately, I'm of an age where I'm pretty brutal. Okay? So we took on a graduate this year after Christmas, and he was basically told, turn up every day, be smart, communicate. Yeah? Listen, don't talk. Yeah? You need to, this is a great course. It's giving you the foundations of where you want to go. But it can't be, it's not career specific, because it can't be. It's electrical engineering, yeah? There's so many parts to electrical engineering, it's incredible. There's so many directions you guys can go in. You can go into defence, Raytheon, go into Collins Avionics in the States if you want to. There's loads of places you can go. So building services is one particular area. So when the graduates come to us, we try and select them from their willingness to learn and their willingness to communicate. Because everything else we can teach you, yeah? In this course, won't teach you how to do lighting counts, won't teach you how to won't do cable calculations necessarily, won't do lightning protection, won't do fire alarm detection, because it's too, our industry's left of centre, shall we say, right? So we expect the engineers to come here, get yourself a decent degree. I don't really care what grade you get, as long as you get a degree. Sorry. It's a case of proving to me that you are capable of learning, yeah? And then we'll take you on board, and then we'll foster you. From someone coming into building services, the guy who's just joined us, we've told him basically 3 years, and then he's going to start doing design work. Yeah, it takes that long to absorb the basics. Yeah, walk before you can run. So we haven't put him under pressure, and you learn different skills. So we take you out to meeting. Let's say about communications. A lot of our thing is about this thing about asking the question, the why, and the how. Yeah, and being able to relay information to a client. So all you guys, girls, you've started writing reports and those sort of things. They're wonderful things. Biggest problem in the university, when it comes to report writing, you write reports as a student or as an engineer for a lecturer. We write reports as an engineer for an end user who might be a plumber, who might be a window cleaner. Yeah, and so you've got to write your reports that are accurate in what they're saying, but they need to be understood by the end user. Right? So hence the communication component and the willingness to learn. Right? Good question, though. Come and see me in a few months' time. Thank you. Sorry, Pop? Okay, within this sort of application for the load you're looking at, it would tend to be a mechanical device. We would look at some contactor that opens and closes. If you try and use solid state for these sort of power devices, you'd be struggling to find that one that's rated for it. So, two things. When you're looking at this device, your card reader will talk to a little PLC, and the PLC will have an output. Fundamentally, that might have a solid state relay in it. But at some point, that's got to break a 240 volt rated circuit. So you might come out of your relay board at 12 volt DC and drive a coil, and that coil then has a contactor that pulls in and out your supply to your bit of machinery. Right? Does that help?
The trick with solid state relays is when do you turn them on and off? At the peak of the voltage or at zero voltage? Yeah, so you typically sense a zero crossing or the peak of the voltage, and you switch during the period. But when do you do it? Do you do it zero voltage or peak voltage? Right, because the VT, right, at zero voltage, the VT is large. Right, so again, you go back to your basic equations. What do you do? So solid state relays introduce this whole other problem. How you switch things.
The other little thing you need to think about when you finish this little example is, how does it fail?
Yeah.
If this device fails, how does it? If this device is to fail, and any mechanical or electronic device needs maintenance, it will fail at some point, unless you test it regularly. So when it fails, what conditions does it fail under? I'll give you a hint. It mustn't fail closed. It needs to fail open. Yeah. So a lot of people, especially with control systems. So what you want to do with a coil that's driving a contactor is, when you want to use the machine, have it powered on. That way, if you have any form of loss of power, de-energizes the coil, opens the contact. So it's we refer to things as normally closed or normally opened in terms of contactors, relays. Yeah. So the normally bit is when it's in the de-energized state. Right? So you'll specify potentially a normally open contact. So you badge, power it, closes. Yeah? The other question you should be asking also with this is, you've badged, you've gone to a machine, you've badged, right, I can use the machine. How long for? How do I take off the credential? How do I give it to the next person? Yeah? So when I badge, is there a time limit? Or do I badge once to bring the machine on and I badge 3 times to bring the machine off? I don't know. Does that just automatically happen when I turn the thing to off? Yeah? Hence why I mentioned this thing about the control methodology. Who's decided what is it? Sorry.
These are all really
Okay, so the idea today is to get you guys to think. All right? Thank you.
Thank you. No, don't interrupt me.
Show some relatives.
The book I'm reading at the moment.
And yeah, just keep it circulate if you want to, for the guys.
That'd be great. Well, hopefully we can, if we put it on LMS.
Yes.
For those people we missed.
Yep. So I've got the slides. So I can just put them.
Yeah. Thank you. All right. Again, stick around if you want, but I'll send you a thank you to follow up. Oh, don't forget this. This is who's had the chance to look at the a standard? Active hands. Thank you. 1, 2. Can I actually have active hands? 3. Who's actually gone and had a look at a standard in the library? I saw 3 hands. 4. Sustained hands. Right? So where are we? 7? Are we? We're 7. We've been banging on about standards. Okay? It's your responsibility to look at the standard. It's your responsibility. I don't care if the team you're in has allocated one person to go away and look at the standard. It's your responsibility, right? And you're failing as an engineer if you're getting through this unit and this degree and not having a look at that standards. You are failing as an engineer.
And we're failing as teachers.
Okay? So, we should just have an exam where I pull questions out from a standard to make you do it, if that's what it takes. But you must look at a standard, okay? Because you can't go out in the industry, put yourself in front of an employer and be embarrassed by the fact that you barely know the name of the standard, let alone cracking it open and having a look at what it might contain. Okay? This is the kind of essential stuff. You know, everyone's saying, what do I need to learn to be an engineer? You have to do this. Okay? And
to be given resources and after 5 years not to have used them, you fail. Okay? Right? You're supposed to be going out to be professional. If you're a doctor and you go, oh, sorry, I forgot to figure out where the heart was. You know, I know we covered it at some point, but I just forgot. Okay? There are some things you expect a doctor to know. You go to see a medical practitioner, you expect them to be competent. You leave this door of this university, the expectation is that you're competent. Thank you. And if you're not, you're letting us down, you're letting yourself down, okay, as engineers, because we're giving you all the resources to do that. It's not acceptable to coast by, all right? Because eventually, you know, if you're not careful, someone dies. Joe, thank you again. Great effort. See you, Joe. All right, so that's the end of banging on about standards, but we will continue to bang on because they are super important. Questions about the project? There were a couple of questions on the online forum. Make sure I'll check if...
There's nothing on the chat.
There's nothing on the chat, okay. I don't want to miss the chat questions. There were a couple of questions to Craig Williams on LMS, so I forward them off. Craig Williams has come back and answered a whole lot of questions which I have posted on LMS. So again, if you have not looked at the answers provided on LMS in the question form, you're crazy. And if you post a question that's already been answered, you will cop it. Okay? So all the resources